Hyphae are the thread-like vegetative part of the fungi, collectively called mycelium, forming decentralized underground networks that absorb nutrients from its environment. One of the primary roles of fungi in an ecosystem is to decompose carbon-based organic compounds such as petroleum. From 2011 onwards, scientists found several fungus that have the ability to digest plastic waste in our environments. One of these fungus is called Pleurotus aspiratus, also known under oyster mushroom. The world's global crisis with plastic pollution is getting worse year after year. Around 300 million metric tons of plastic waste are produced annually, out of which 10 million tons enter the ocean each year, adding up to approximately 150 million tons already circulating our oceans. At least 1 million seabirds and 100,000 marine mammals die yearly because of plastic-related deaths. By 2050, scientists believe there will be more plastic in the sea than fish. Due to the fact that plastic degrades very slowly, most of it will remain in our environment for centuries. Macroplastics will first break into mesoplastics, then into microplastics, and finally into nanoplastics. This has severe effects on marine life as they mistake plastic waste for food or get entangled in larger pieces. This is the cause for many plastic-related deaths of marine species. This map illustrates the amount of plastic already circulating in our oceans. One dot represents 20 kilograms of plastic. In terms of plastic waste generation per year, China is the front runner with 59.8 million tons per year, followed by USA, Germany, Brazil, and Japan with 8 million tons. Osaka is the capital of Osaka Prefecture in the Kansai region and ranks as the third biggest city in Japan. A recent study found that there are currently 3 million plastic bags along with 6 million other pieces of plastic floating in Osaka Bay. The following maps show the circulation of plastic in Osaka using the shortest walk path. Starting with the shops, plastic travels to the households, then to the recycling plants, and lastly to the docking areas and landfills. These pathways were then simulated in a time span of 2 days to reveal the areas of high-density plastic circulation. When looking at the end of the plastic's lifespan in Osaka, the areas of high density are situated on the artificial islands, which brings me to Yumeshima Island. Yumeshima is located in front of Osaka mainland and opened for public in 2002, but is still under construction. The island is therefore in a constant state of topological transformation. The material experiments consisted of using plastic waste as part of the fungi substratum. Oyster mushroom injected straw substratum was mixed with shredded plastic waste, cardboard and water. The mixture was then placed in a transparent box. The time span of the mycelium growing to the mixture took 7 days. When the mycelium has grown to the whole substratum, the fruiting body of the mushroom starts to reveal itself. For the system test, a part from my catalog was printed in 3D in a 1:5 scale. The idea is to let the mycelium plastic mixture grow inside the 3D printed shell. After 2 weeks, the fruiting body of the mushroom should start to make their way through the structure and slowly degrade the plastic mold. Coming up are 2 time lapses. The first one is the mycelium growing through the structure, and the second one is the fungi growing out of the mycelium and the structure. Input data for my drawings consists of the original mesh, a displacement map, highest and lowest points from these meshes, and the resulting proximity network. In the catalog, the shortest walk from plastic waste to the actual site resulted in several input points. One part of these input points are coming from landfills, the other part is coming from ocean plastic waste. From there, agents start their growing process, generating fibers that follow the logic of the proximity network. Zooming in for the final drawings, a more detailed and denser proximity network was generated with a new fiber system applied to it. The growth input comes from the plastic waste that is brought to the structure from land and sea. The Fibers start growing from these input points and make their way through the proximity network. An ever-growing three-dimensional structure emerges, made out of mycelium and plastic that remains there until the structure has itself biodegraded.